It has a lot to do with my family background. Uh, my father came from China. He is a blue collar machinist in a shipyard, repair shipyard. And our bread and butter come from his engineer, who is a British engineer. And we were grateful to him because he gave us a job, he gave him overtime, and he was animal with him. He was really by him. So I thought to myself as a young boy that one day I will try to be an engineer. So I continued that interest. In fact, I ran to the first technical school in Singapore, Queenstown Technical School. There are only two technical schools. The leading one is Queenstown. So I ran there to do my Sec 1 to Sec 4, and we were the first batch to do technical subject in O-level Cambridge. First batch, metalwork, technical drawing. So all the way I chart myself to be in that direction of being technical and an engineer. So I entered into NUS. I started my interest in mechanical engineering, not so much in electrical and not even civil. But later on in life, I was interested in design. When I say design, it's more in the building design. Why is the rooftop like this? Why a condominium built this way? So I was interested in building design. And therefore, when I entered into University of Singapore, I chose civil engineering rather than mechanical engineering. So it was more my inclination to look at building blocks, building design. But I didn't know that civil engineering is more than just building. Actually, building blocks and all that are structural engineering. But in civil engineering, you're talking about a large area. As I told you, I was taught geology, right? And then you have foundation. And then you have technical engineering. And when I was in Changi Airport, I was an engineer doing consolidation of marine clay. And that was a big interest to me, very big interest. How do we consolidate the marine clay to avoid resettlement for the airport? So it's a wide area but of course, actually, even in the final year, I realized that civil engineering is not just about building and structure. It's also environmental. In fact, we have a subject in final year called environmental engineering. And the lecturer teaching me was a professor called K.K. Chin. K.K. Chin was in fact the dean of engineering. And he was an environmental engineering expert, not civil and structure. So I realized that civil engineering is much wider. In fact, I would say much wider than the other branch of engineering. Well, my first job after graduation was in the Ministry of Defense. In fact, interestingly, I was the very first civil engineer in the Ministry of Defense, first engineer. But at that time, we were doing a lot of maintenance, facility management, building camps and firing range, for example. But we have the opportunity to also manage two military air bases, Tengah and Seletar, in terms of the facilities, the runway. And I was very interested in the runway system because to repair a runway is a very big deal. So when I finished my bond with the Ministry of Defense, I asked to go to PWD, Public Works Department, to be able to do airport engineering in Paya Lebar Airport. So I was posted there. But within 2 years I was there, the government wanted to build Changi Airport. That was a real pivotal, because Changi Airport is then the biggest national project in Singapore, the largest in scale, in amount, in complication. The whole airport. And that was a pivotal moment. In the building of airports, I think the most challenging were two things. One was the consolidation of marine clay, as we said, because Changi Airport, 70% is reclaimed land. And under the reclaimed land, you have something like 30 to 60 meters depth of soft marine clay. They will consolidate. It will not sink straight away, but over time, consolidation will take place, and your runway and your taxiway and airplane will sink gradually. It's a very serious problem. So we think of ways to how to treat this marine clay so that this post-construction settlement will not happen. And this is a very tricky thing because it's very hard to convince the government that you need to do this because it's a problem that will take place much later. For example, the time Penang was building a runway, and they also have soft soil. They didn't do any consolidation. So we were asked, how come we need to do consolidation? I remember our program to do consolidation was 40 million. 40 million in the 70s is a lot of money. So we were queried, why do you need? We say, well, we want to avoid the runway from consolidation for settlement. The government accepted us. Guess what happened? A few years later, Penang runway was wavering. And they will ask us, they then ask us for advice. So we prove our point that there is a problem that will come later on, but you have to arrest it now. And that is the problem of control. So marine clay settlement was a big issue because 70% of the area affected it. But later on, of course, building the terminal building was a big thing because the Terminal 1 was the largest building project in Singapore again. The terminal building, Terminal 1 is about 3 million square feet. It's not only big, it's complicating. To build a terminal is not a public building that is so easy because you have passengers, you have luggage, you have airlines, and you have safety, and you have all the navigational instrument to integrate with. So building a terminal was a big challenge. In fact, building a terminal is probably the most difficult public building to be done. Public building where you have passengers, you have the public using it. So the terminal building itself, I was in charge of Terminal 2 later on. I was the chief of the Terminal 2. So those are my challenges. Well, I remember in my third year, I had to do a research project. It's to study torque. I mean, you are civil engineer, to study torque, torque. Under compression, what is a torque strength? So I have to design, I mean, at that time we have to design the experiment, how to do the test sample, how to do compression and torque, and then try to see how does compression affect torque. Those stays in my head about the testing of not normal concrete under compression, but under torque. That one I can remember. Well, I am personally very keen on digital experiment, doing visual things, virtual things and all that. But I still think that you can't run away from actual physical tests. Well, there are two things that I'm very proud of in my life. It happens to be quite significant one. One is to build Changi Airport. I spent 20 years there from day one, from 1975. I built the first runway. I was building the first runway, and Prime Minister Lee Kuan Yew flew in the helicopter to see, flew in the Skyvan to see. So my involvement in Changi Airport was really something that was very fundamental to my background. Then the second time was when I built up a company called CapitaLand. I was a founder CEO, and I built it up. Of course, CapitaLand is in real estate. We were actually one of the biggest developers in Asia Pacific. It's not just a real estate company to buy and sell properties. We actually develop these properties. And under that organization, we built a lot of things. We built something like 67 malls in China, shopping malls. We built thousands of residential and homes. So those are also civil engineering in the background, and I'm very proud of those things. Surely later in the future, engineering will have to be a very integrated subject. You cannot just do pure civil engineering. You've got to really be able to integrate the other branch of engineering or the other discipline. In engineering itself, things are getting more and more integrated. For example, design, you cannot just do civil engineering. You've got to understand a lot of things more. But more than that different branch of engineering, you've got to integrate with technology, right? Technology is actually from engineering. but technology becomes a different level of using engineering. So I can see the trend is that you got to be able to use engineering, whether civil engineering or electrical or mechanical, convert it into technology, convert it into larger ambition. That's why you have people going into biotechnology, people going into product development in medical science. That is engineering, but in medical science. So the future is that you cannot be defining your expertise in one area, but prepare to go into technology, prepare to go into AI, digital design, things like this. That must be the trend. If you want to remain as a civil engineer, you can still do interesting things, but your scope will be limited. Well, my hope first and foremost is that young people, more and more young people take up engineering. I'm so sorry that in Singapore, for example, the interest in engineering is diminishing. Something that I try to advocate, I lobby the government, but the standard must be kept. I mean, with due respect, I told the ministers, DPM, Leong, I said, now your admission to university, BCCD also we can get in. Right? You're getting poor quality students. So I say you must do something about. Of course, why are the poor quality students getting into it? Because you set the standard where somehow it's a chicken egg, they can come in, right? They can come in. Then the better quality students, oh, I don't do engineering, I go do this more high level one. So something must be done to say that engineering as a subject of learning, preparing for your career, is something that we have to promote, and we are not promoting it enough. I told the government, look at the stock market. 43% of the stock market requires engineering. 43% of the companies in the stock market require engineering. What happened to the company if 43% of the company don't get the best engineers? Simple. So it's very important. So what do we do about it? There are a lot of things you could do about it. Increase the competition, promote it, go and give talks. There are many things. Go and inspire students to do engineering. I came up with a program many years ago to your faculty. I said, send the engineers who have done the past, now they are civil hair. Go and talk to the students. If I talk to you about ship repair, I bring you to a ship repair shop, you will be interested. If I talk to you about airport engineering, you won't be interested. I bring you to airport to see our construction, you'll be interested. If I talk to you about tunneling, I bring you to LTA, you'll be interested. I will say the reason why I choose engineering. I will tell you the benefit of me. I'm not a scholar, right? I have never been a scholar, but I did well. I did well in life because I studied engineering. Why? Engineering is a subject that teaches you to be numeric, to teach you to be analytical, to teach you how to understand logic, to teach you how to understand the big picture of things, right? Believe me, if you study engineering, it's a very good preparation for your faculty. I practiced engineering for 20 years, then I became a business leader because of my engineering training, not because of my engineering, right? So the preparation for an individual to receive an engineering education is very important. I can tell you, anytime I will take an engineer to do important things in leadership, than to take a science graduate or to do a business ed graduate. Some of my top people are engineers in training. Of course, some of them may not practice engineering, but the training is there. So I will tell them that treat this as a preparation for your future. Not straight away you get a job that is $6,000. Right? Where is your future? Whether you study engineering or medicine or some other thing, it's what do you call a specialization. So when you look at career and what happened to you, There are two routes. You can be a specialist civil engineer, soil improvement, structures, environmental. These are specialists. But after sometimes in life, you can look at no longer specialization, but generalist, become a generalist. When you become a generalist, it's important that your specialist training help you out to become a generalist. You know more and more, but less and less. When you're a specialist, you know less and less, but more and more. But we are generalists, you know less and less, but more and more. So I think this is an interesting question of understanding how you can become a specialist first, then become a generalist, then you become what I call a leader, or a manager, or something that is a generalist to go up in life. You cannot remain. Of course, some people can become a specialist for the whole life. You want to be a medical specialist, you want to be a cancer specialist, good. I mean, those are things that are very customized route of progress. But some of us will become managing director, CEO, chairman, and for that you need a generalist training. I'm very happy to be invited here to say something, to be interviewed for the CEE, Civil Engineering Environment Department. It's a great place to be in, great place to relay some of my story. And I want to say happy anniversary to the CEE department and best wishes to them in the future endeavor. Thank you.